Let's start with paper 3 of electric potential and capacitance. Our question number 1 says the voltage needed to balance an oil drop carrying 10 electrons. So let me write here the number of electrons here given as n equal to 10. When located between the plates of a conductor, which are distance here is 5 millimeter given as per the question, which is 5 into 10 raised to minus 3 meters apart, taking g acceleration due to gravity as 10 meter per second square, right? And the mass of the oil drop, okay, that is m, will be equals to 3 into 10 to the power minus 16 kg, correct? So here we have this is our data given, and what is asked? Voltage. Okay, so we have to find. We know that if the oil drop is experiencing some drop, some force, this force is given by electrostatic force F equals to QE, correct? And Q will be equals to number of electrons, so N E E. This will be the force, right? And this force is electrostatic force, and this is balanced by what? Gravitational force, which is equals to the weight. So mg equals to N E E. Still, m is given, yes. G is given, yes. N is given, yes. E is what? 1.6 into 10 raised to minus 19. We know that. What about electric field? That is not given. And question, what is they are asking? The potential. So we know the relation between field and potential, that is given here as voltage upon length, correct? So length is given, yeah. So I have taken it as d. So let me put here d. So if you put it here, so V will be equals to nothing but mg into d whole divided by n into E. So that will give us the voltage which we should place, okay, or we should keep in our conductor's plate so that it will balance these number of electrons. So here it will be, what is the mass given as per the question? Mass is given here as 3 into 10 to the power minus 16. G here is given as per the question 10. Separation is given 5 into 10 to the power minus 3 whole divided by number. Number is how much? 10. And number of electron and charge on an electron 1.6, that you have to remember, 10 to the power minus 19. Correct? So let's simplify it further. So 10 cancels with 10 and we left with 15 over 1.6 into 10 to the power minus 19 on the top and whole divided by 10 to the power minus 19 in the bottom. So when you divide 15 upon 1.6, what we get? We get nearly 9.37. Okay. So here there is a small misprint. This should be 9.37 instead of 9.47. Okay. So that is a typing error. Let's move to question number 2. Question number 2 says an infinite plane sheet of charge density. Charge density, what is our charge density from first chapter? Sigma. That is given here as 10 to the power minus 8 coulomb per meter square. So by looking at the units, we know that sigma is nothing but charge upon area, right? In this situation, how far apart are two equipotential surfaces? We have to find d, okay, distance, how far apart they are, whose potential difference is, voltage is given here as 5, right? Now if this is a thin sheet, okay, infinite plane sheet, okay, from first chapter Gauss's law application, we know that sigma is nothing but the electric field is nothing but sigma by 2 epsilon naught. That is one side of the sheet, right? So if electric field is sigma by 2 epsilon naught, what is electric field? Potential upon length, right? That is equals to sigma by 2 epsilon naught. And if you cross multiply, we will get the length or d. Okay, so let me just put this L as d. So d will be equals to V into 2 epsilon naught upon sigma. Let's put here. So V is 5 into 2. What is epsilon naught? 8.854 into 10 to the power minus 12. You have to remember this constant, permittivity of free space. Sigma, 10 to the power minus 8. Let's simplify it. Okay, so 5 2s are 10. So this will be 10 into 8. This will become 88.5 into 10 to the power minus 8 goes up minus 4. Okay, that will be in the meters. So let's see if we have such an answer. 88.54. Okay, so if you shift, okay, you will get 8.85 into 10 to the power minus 3, and that is nothing but 8.85 millimeters. So correct answer here is option B, 8.85 millimeters for question number 2. Let's start with question 3. 3 points are given here, A, B and C, okay, in a uniform electric field. What is a uniform electric field? Okay, at each and every point the value of field doesn't change. Okay, And what's the value of this? Our value of this of uniform field is 5 into 10 to the power 3 newtons per coulomb, as shown in the figure. Okay, the potential difference between A and C we have to find. Okay, so if it is a uniform field, one thing you should know that potential at point B will be equal to potential at C. Why? Because that will create an equipotential surface, right? Okay, this separation, this whole perpendicular which you will draw, okay, this perpendicular thing will have a constant potential. So we can find the potential at B and we can find the potential at A, and we can subtract both. Okay, so how do we find potential difference? First we have to find the gap AB. So AB is 4 centimeter. Sir, how do you know AB is 4 centimeter? Pythagoras theorem. AB square will be equals to our AC square minus BC square. And when you put AC as 5, it will be 25 minus 9, and that will give you 16. So AB is 4, correct? If AB is 4, let's find now potential. Okay, so potential V will be equals to electric field into that AB distance. So what is our electric field? 5 into 10 to the power 3, and AB is 4, right? 4 centimeter. So that will be equals to 200, okay, and into 10 to the power 3. So here this will be, centimeter is there, so I have not used 10 to the power minus 2. So I have to use here 10 to the power minus 2, and 5 4s are 20, not 200. So that's a small mistake here, 20, and this will give us 20 into 10 to the power 1. So that is 200 volts. That is the potential difference. So correct answer is option B for question number 3. Let's move to question number 4. 2 point charges, this and this are separated by a distance of this. The potential energy you have to find. So what's the formula for potential energy? U equals K Q1 Q2 upon R. Is it a scalar quantity? Yes. So signs are important? Yes. So 9 into 10 to the power 9. What's the first charge? 10 into 10 to the power minus 6, because microcoulomb. And second one minus 10. Be very careful here. You have to take the negative sign into consideration. R is how much? 2 centimeters. So 2 into 10 to the power minus 2, right? Now further 9 into 10, 90 into 10 to power 3 into, I am taking minus 10 into 10 to the power minus 6 whole divided by 2 into 10 to the power minus 2, correct? Let's simplify further. So this will be minus 900 whole divided by 2 into, let's solve the powers. 10 to power minus 2 goes up, it becomes 5 and minus 1. So this will give you minus 450 into 10 to the power minus 1, and that is minus 45. And what's the unit of potential energy? Joules. So correct answer is minus 45 joules, option B. Let's move to question number 5. Question number 5 says a point charge, 2 point charges A and B of value this and this are kept 18 centimeter apart. The work done when the charge B is moved by 3 centimeter. It's not 3 centimeter by 3 centimeter, which means we have to find first the potential energy U1 when they were 18 centimeter apart. So K Q1 Q2 whole divided by 18 centimeter, 18 into 10 to the power minus 2, correct? Then we have to find U2. So first let me find U1. That will be how much? 9 9s are 81 upon 18 into 15 into, let's solve the powers, 10 to power 9 and 10 to power minus 12. On 10 to power 11 and minus 1 it will become. So this will become 3 5s, 3 6s, and 3 2s, and 3 27s. Yeah, and this will become 27 into 5, okay, 27 into 5 upon 2 into 10 to the power minus 1. So this will be how much? 5 7s are 35, 5 2s are 10, 13, 135 upon 2 into 10 to the power minus 1, and this will be 2 6s are 12, 15, 14, 67.5 into 10 raised to minus 1, and that is 6.75 joules. Now this is the energy when they were 18 centimeter apart, right? Now you have to find the energy when they are moved by 3 centimeter. So if you are keep getting them little closer by 3 centimeter, which means what's the new gap? 15 centimeter, right? Let me repeat. Initially, if they were at 18 centimeter apart, Now if you are getting them or moving the charge B by 3 centimeter, you are keeping them at 15 centimeter. So let me get here U2, that will be K Q1. What is Q1? 15 into 10 raised to minus 6 into 9 into 10 raised to minus 6 whole divided by, what's the new gap? 15 centimeter, 10 to the power minus 2. Let's cancel this with this. 9 9s are 81 into 10 to the power 9 and 11 minus 1. This gives you 8.1 joules. Okay. So previously the charges were away, so their potential energy was less. Now they are coming closer, so the potential energy increases. So what is the change in potential energy? So let me write here delta U, that will be equals to U2 minus U1, and U2 is how much? 8.1 minus how much? 6.75. So when you subtract both, you will get our answer as 1.35 joules. Let's see if there is any answer like 1.35 joules. Yes, option B is correct. So be very careful when they are taking the charge from initial configuration to any such final configuration. Let's move to sixth one. 2 point charges, this and this are separated by a distance of this. The point on the line joining the charges where the electric potential is 0. So let's solve this. First of all, 20 into 10 to the power minus 6 here. Second charge, minus 4 into 10 to the power minus 6 here. Separation between them, what is that? 50 centimeters. So 50 into 10 raised to minus 2. Okay, this is A, this is B. Let's say at any point P, the net potential is 0 and this is at X. So this will be 50 minus X, right? So potential at P due to A will be K Q1 divided by separation, which is X. Next is potential at P due to B, K Q2. Again I am repeating, you have to consider the negative sign because potential is a scalar quantity. So negative sign will be considered upon 50 minus X. So net potential at point P will be VPA plus VPB. Now what is VPA? VPA is 9 into 10 to the power 9 into 20 into 10 to the power minus 6. Okay, whole divided by X minus 9 into 10 to the power 9 into 4 into 10 to the power minus 6 whole divided by 50 minus X. Left side it is 0. Why? Because question is saying the potential at that point is 0. Let's take it on the left hand side. 9 into 10 to the power 9 into 4 into 10 to the power minus 6 whole divided by 50 minus X is equals to 9 into 10 to the power 9 into 20 into 10 to the power minus 6 whole divided by X, right? Now let's cancel out this with this, this with this. We left with how much? 4 upon 50 minus X is equals to 20 upon X. Let's cross multiply. So this will give us 4X is equals to 1000, okay, minus 20X, correct? So 5 2s are 10 and 2 zeros, yes. So 1000 minus 20X. Now let's take 20 on the other side. 24X is equals to 1000, correct? So let's divide 1000 by 24. That will give us X is equals to, which implies 41.66 nearly. So this is our value at which the potential is 0. Let's see, is there any option 41.66? Yeah, nearly 41 centimeters. So option C is correct. Okay, for question number 6. Let's move to question number 7. Seventh one says 2 point charges, this and this separated by this, the potential energy of the system of charge. So how do we find potential? Be very careful with the potential and potential energy. Potential energy is U equals K Q1 Q2 upon R. Okay, potential is KQ by R. Only one charge will have a potential. Potential energy here is system of a pair of charge minimum. So this will be 9 into 10 to the power 9 Q1. What's the Q1? 20 into 10 to the power minus 6 Q2 minus. So you have to consider the sign. Potential and potential energy both are scalar quantities. Signs are important. Separation is 50 into 10 raised to minus 2. Let's simplify it. So this will become 4 and 9, let's keep the numbers together into minus 4. So I'm taking negative sign in front, into 4 whole divided by 50. And powers, let's group them together, 9 to 11 and 12 minus 1. So this will give you on the numerator, let's multiply 9 into 20, 180 into 4, that is 720. And this will be minus 720 upon 50 into 10 to the power minus 1. So 720 divided by 50 is equals to 14.4. So minus 14.4 into 10 to the power minus 1. So our here we got as minus 1.44 joules. That's our potential energy. So minus 1.44 joule, option B. Let's move to question number 8. Question number 8 says two charges, okay, they are going, magnitude is 5 nanocoulomb. So Q1 is, now let me just write, okay, or we can draw here because they are saying at some point. So initial, this is at 5 nanocoulomb. And another one is minus 2 nanocoulomb. Are placed at what point? One is placed at 2, 0, 0. So this is 2, 0, 0. And another is x, 0, 0. So what's the separation? The separation between them is x minus 2. Correct? Yeah, this is simple coordinate geometry. The separation between the point A and B will be what? X minus 2 centimeters, right? So 10 to the power minus 2. Where there is no other external field. Okay, so no external field, only these two charges are. If the potential energy of the system is given by, so U is given here in this question, 0.5 microjoules. Micro is 10 to the power minus 6, right? Joules. So be very careful, you have to do conversion, okay, here, and we have to find the value of x. So potential energy between two charges, we know it is K, Q1, Q2 by R. Let's substitute the values. What is K? U is 0.5 into 10 to the power minus 6. What is K? 9 into 10 to the power 9. Charge Q1. Q1 is how much? 5 into 10 to the power minus 9. And what is charge Q2? Minus, be very careful, minus sign is important, 10 to the power minus 9. Whole divided by, the separation is x minus 2 into 10 to the power minus 2. Correct? Now let's simplify it further. So first of all, 10 to the power plus 9 and minus 9. Let's remove this. And we left with here as 9 5s of 45 and into minus 2 into 10 to the power minus 9. And 10 to the power minus 2 I am taking on the top. It will become plus 2 whole divided by x minus 2. So this will be on the left hand side 0.5 into 10 to the power minus 6. Let's cross multiply. So x minus 2 will come on this side and this will be 45 2s are minus 90 into 10 to the power minus 7 whole divided by, that will go down. So 0.5 into 10 to the power minus 6. Correct? And here we can take this 10 to the power minus 6 on the top and make it minus 1 here. So this will be minus 90 upon 0.5 into 10 to the power minus 1. Correct? And this minus 1 and taking down, that will make it as minus 90 upon 5. X minus 2. Correct? So this implies x minus 2 is equals to minus 5 ones are 5, 18. Correct? And this goes that side. So x is equals to minus 16 centimeter, which is on the negative side. Right? So this is very, very important. Okay, x minus 2 here it is. Okay, so let me recheck it. This is placed at point this and this. So separation is x minus 2. So maybe they have taken the magnitude. Even 2 minus x is possible. Okay, the gap between them. Maybe the charge, this 5 nanocoulomb that is placed on the other side. This is on the other side. So minus 16 is, I think, okay, we'll go for none here because, okay, so correct answer here is option D, none. Okay, okay, because the magnitude is coming negative. Okay, potential energy. Okay, let's move to question number 9. The work done in assembling 3 charges Q, Q and minus Q at the corners of an equilateral triangle with side length A. So we have to find a potential energy here. Work done is potential energy. So let's place the first charge here, Q. What is the energy required to place it there? 0. Because nobody is there to influence this charge. Now we are placing the second charge at this point at Q. At what distance? Our distance here is A. So let me just join this point. This will be our A. Okay, this gap is our A. So what is the potential energy now to put it there? U2. That will be K Q1 Q2 upon separation, which is A. Now I am placing a third charge. Where I am placing a third charge? At a distance of A from second charge, and at a distance of, wait, I'll just make it here, okay, straight line here at a distance, and the second one at a distance here. This is also A and this is also A, and the third charge is minus Q. So if I am placing minus Q, what is U3? The U3 will be, this charge will be influenced by the charge on A. This is C, this is B. So U3 will be, charge AC will be K Q into minus Q. Keep the signs upon A. And what's the potential energy required against the second charge? It will be plus K Q into minus Q upon again A. Okay. So net potential energy required to assemble these all charges will be U1 plus U2 plus U3. That will be, when you add all of them, this will be KQ square by A. Be very careful, U1 is 0. So I am directly putting the value of this is U2. Okay. And U3 will be minus KQ square by A and minus KQ square by A. So we can cancel this with this. We left with minus KQ square by A. That is option B. This is the correct answer for 9th one. Let's see the 10th one. So 10th one says the work done in assembling 3 charges, 2 coulomb, 2 coulomb and minus 2 coulomb at the coordinates of equilateral triangle. Quite similar. So I am placing here a 2 coulomb charge. What is the potential energy required to place it there? 0. Why? Because it is not having any influence by any other charge. But now if I place another charge, it will be experiencing a force, a repulsive force due to the first one. So we have to do work against it. So U2 will be equals to K Q1. Okay, so I am not writing C. C is just coulomb. So 2 into 2 upon separation. What's the separation? 1 meter. Now let's place the third charge. Third charge, it will be influenced by the first one, minus 2 coulomb. So let's see the interaction between first and third. That will be K into 2 into, be very careful, negative sign is important, upon 1. And it will be influenced by the second charge as well. So it will be plus K into 2 into minus 2 upon 1. Correct? So let's add all of them. So U will be equals to U1 plus U2 plus U3. So this will be 0 plus 4K minus 4K and minus 4K. Let's cancel out this all 4K and 4K. We left with minus 4K. K is what? 9 into 10 to the power 9. So it will be minus 36 into 10 to the power 9 joules. Correct? So that is correct option B. I hope this is clear. This was paper 3.